Welcome, everyone. My name is Ricardo Camacho, and I'm the Director of Regulatory Safety and Security Compliance at Parasoft. Today, I'm here with Miroslav Zielinski, Director of Product Management, and we both thank you for joining us today for this webinar to go over using GitHub with static analysis in your CI/CD pipeline. This is going to be a very informative presentation, so let's take a look at the agenda. To put things in perspective and give you a glance and hopefully a broad scope of understanding related to modern Agile development workflows, I'm going to start with putting Agile in context and how that relates to team collaboration and methodologies used. Then, how DevOps and continuous integration and continuous delivery fit into this picture. And I'll step you through a quick description of each of the stages in the DevOps workflow to do this. Then Mirik's demo comes next. Now, because Mirik is in Europe and far away from sunny San Diego, California, we decided to record it. In the demo, Mirik will take us through a live recorded CI/CD workflow starting from writing code to delivering it using our GitHub integration with Parasoft C++ test. It's going to be very educational, and then Mirik and I will open it up for live Q&A. All right, let's get started. Now, to give you a little history on Agile, back in 2001, a group of folks with various software development backgrounds met and they discussed the difference between development practices that existed at the time, like extreme programming, if you remember that, and feature-driven development is another. To cut the story short, they came up with what is known as the Agile Manifesto. They realized that there were these overarching values related to how people should collaborate internally and externally within an organization. Not just to develop better software, but to help each other develop better software. So they came up with 4 rules and 12 principles, as you see here on the slide, and that helped establish the Agile mindset or philosophy. As you get familiar with the rules and principles, a theme around interactions, collaborations, cooperations will actually emerge. This is key because a core component of Agile is breaking the silos within teams and organizations and have them work closely together. Another core value is responding to change, which is supported by principles number 1 and number 3, which are about continuous delivery and delivering software frequently. These core values and principles can be found in the way things are done in Scrum, Kanban, DevOps, and others. Note that these methodologies support Agile values and principles. Therefore, they are correctly referred to as Agile methodologies. Hence, Scrum is Agile, but Agile is not Scrum. Agile is not a methodology. I wanted to make this point because there's a lot of questions around this out in the field. If not all of you, most of you are familiar with the Scrum project management methodology, so I'm not going to spend a whole lot of time here. But we use it here at Parasoft for our software development, and it brings cross-functional teams together to work towards a common product vision and goals in delivering our software solutions with openness, transparency, and respect. We have sprint meetings to synchronize. In these meetings, we determine what is being delivered, what didn't get done or completed, and needs to go to the backlog. We also check if any requirements change and how to manage that change. And there are also important roles people play within Scrum. To put it in a nutshell, Scrum promotes a smaller way of working that allows the team to accomplish more within a given time frame, and what is being delivered is fairly predictable. The ideal Scrum team is a group of highly flexible and adaptive individuals who thrive in the context of an iterative and incremental delivery structure, and they're not afraid to also give a little bit of advice or feedback and receive it as well. Also, you have Kanban, which again is very much about teamwork and very human interaction driven, all for the purpose to better support collaboration between people. I've been to companies where walls and meeting rooms are filled with post-its from them having had a planning meeting. It's actually kind of a cool sight. And for large organizations with multiple products and projects being run simultaneously, there is the Scaled Agile framework. SAFE is the acronym. SAFE is a set of organizational and workflow patterns for implementing Agile practices at the enterprise scale. The framework is a body of knowledge that includes structured guidance on roles and responsibilities, how to plan and manage the work, and the values to uphold. We have multiple customers using SAFe, and they report 50% reduction in defects and also time to market, and actually an increase in product by at least over 30%. So Scrum, Kanban, SAFe are popular agile methodologies in support of people working together. But what about software development methodologies that incorporate the tools and automation in support of agile? You have DevOps just for that reason. Automation and tools with steps or stages that enable continuous integration and continuous delivery. It automates the software development process by managing all the tasks that people are working on while also keeping it all together in a copacetic order. Putting it in a few words, DevOps mechanizes and automates manual tasks. It breaks down team silos and increases productivity. I'm sure you have all seen the infinity symbol with the various stages in development, which graphically represents a continuous and iterative approach. I'll very quickly describe each stage and also illustrate some of the tooling that is commonly used in embedded development. But before I do so, I'm going to draw that bridge between agile methodologies and industry functional safety standards like ISO 26262 for automotive, IC 62304 for medical, DO 178 for avionics, 61508 for industrial automation, and many of the other functional safety standards. With these standards that I just mentioned, you will find a V model diagram, and it expresses each of the software development phases that need to be performed in order to achieve a maximum safety level assurance. Here's an example of the V model graphic. It captures the software development lifecycle phases that embedded safety and security critical systems need to go through. On the left side, you have requirements analysis, then high and low level design, and then implementation. On the right side, you have the various verification validation phases for each of the abstraction levels in the software development lifecycle. For example, static analysis can be performed before any code execution. Then you have unit testing, integration testing, system testing, and acceptance testing at the top. The V model is not a methodology. The V model is used to express a required set of development phases. These safety standards describe what needs to be done and stay away from how it should be done. The how is left up to the organization to decide. So it won't say that you have to use the waterfall methodology or any other methodology. It is up to the organization to choose the best fit software development methodology that works for them and their project. Okay, heading back to DevOps, continuous integration is where software development begins, and it will typically iterate several times before code is ever deployed. This happens on the left side of the infinity, and it involves tools that automate the workflow. Here you have the infinity adorned with various development tools, code editors like VS Code, Eclipse, archiving tools like GitHub, test tools like C++ Test, compilers like GCC, CMake, and perhaps you use containers like Docker. There is Jira for project management, among other things, and there are many other DevOps solutions like GitHub, Azure, and we're actually going to get to see GitHub in action that Merrick is going to show us. Planning is the first stage. Here you identify your requirements and what you're going to deliver at each iteration. Jira is arguably one of the most popular tools for agile project management. Code is where the engineer works off of their own development branch, not to disturb the well-tested and working main development branch. Here I'm showing configuration management tools like Git and IDEs like VS Code, Eclipse, and actually Parasoft C++ Test is integrated into these various IDEs, so you can start analyzing and fixing your code as you write it, and actually even before you do a build. Now, jumping into the build, which is the next stage, it gets triggered by committing or pushing the code. Here the code is compiled and built. Again, automation is a core part of DevOps. So these tools that you can see can be integrated to various degrees. And there are other things to consider, such as the use of Docker containers and other types of containers. Then you have testing. Upon a successful build, test automation is automatically invoked. Test methods like static analysis, unit testing, regression testing, and structural code coverage can be performed. Parasoft C++ test easily integrates into this automated CI pipeline, as Merrick will demonstrate in the demo. And he will keep it to static analysis in the interest of time. Release is the next stage, and this is based on the success of your testing. If no bugs are found, the code is merged into the main branch. Now imagine multiple engineers working in parallel in this automated continuous integration cycle until you have an actual version of an application to deliver. Remember that you also have Scrum coordinating the collaboration between people and teams in the organization. Now, all of this together makes the team more efficient, makes the code in a higher quality, and you're able to manage these releases much, much better and easier. Moving into the next stage, we are now delving into continuous delivery. You see the word deploy, but in embedded development, particularly for safety and security critical applications, there is typically an approval process such as acquiring compliance certification. This is commonly done for medical devices, avionics systems, automotive applications, and for many other embedded systems. Organizations cannot just deploy code out to the field as it is commonly done in enterprise IT, for example, web applications. However, since Parasoft supports testing of both embedded and enterprise type of applications, I've kept deploy in the infinity diagram. Also, I've put some logos of tool solutions to help in delivering and deploying applications. Operate is the stage where the application or system is now live and being used by customers, and your organization is making sure that everything is running smoothly. Monitor is the next stage where field or customer feedback is collected, and you also take the opportunity to go look for inefficiencies in your DevOps workflow to make the necessary fixes and corrections. Okay, let's get to the fun part and see the demo.
Hello, I will demonstrate how Parasoft C++ test integrates into GitHub workflows. We're going to see how easy it is to create a GitHub workflow with C++ test static analysis, how to access static analysis results in GitHub, and how to download results from GitHub account to VS Code for convenient remediation. For the demonstration, we'll need a GitHub account with a repository for the demo project, Linux workstation with Parasoft C++ test, GNU GCC compiler and Visual Studio Code, and a GitHub self-hosted runner configured for executing build and test workflow, which we'll set up on the workstation. During the demonstration, we'll go through the following steps. Create a demo repository in GitHub and add an example project to it. Prepare and configure the GitHub local runner. Define the GitHub workflow with the C++ test static analysis. And with all this in place, we'll simulate a simple use case with developer pulling the code, introducing changes using VS Code editor, and pushing the code back to the repository. Push operation will trigger the workflow with static analysis. Static analysis results will be published and available in GitHub for inspection and downloading to the local developer desktop. So let's start with creating a new repository for our demo project. I will switch now to my Linux environment. Now I will open the browser and create a new repository for our demo project. I will call it GHDemo. Now let's add some source code. We'll use popular timer project from C++ test examples. In the home directory, we have C++ test installed. Let me go inside and switch to examples/timer directory, where we have our example source code. This is a simple project we'll be using for our demonstration. Let's add this source code to our fresh repository and commit it. Great, we have some source code in the repository. We are ready to start development. The next thing we want to do is to configure the workflow, which requires configuring GitHub self-hosted runner. We'll use our demo machine as a self-hosted GitHub runner. Let's go to GitHub settings, select Actions, and then add self-hosted runner. GitHub displays a collection of commands for downloading and configuring the self-hosted runner, which we can copy from here and execute in our system. I will open a terminal and create a directory for the runner. Now let's download the runner and unpack it. Great, we are almost there. Now we need to configure the runner. Let's name it Demo Worker and proceed with the default settings. It is now configured and we are ready to run it. Great, our self-hosted runner is up, waiting for GitHub commands. And we're ready to define our workflow. Let's move back to GitHub and set up our workflow with C++ test static analysis. We need to click on Actions and then select Set up a workflow yourself. For our workflow, we'll use a GitHub action for running C++ test that is available in the marketplace. Let's type Parasoft in the marketplace panel, select Run Parasoft C++ test and click here for more details. If we scroll down the action description, we'll find an example of the workflow that is pre-configured for CMake based projects, which happens to be also used for building our example code. We can copy the entire workflow definition from the actions description and go back to our new workflow and just paste it. Before we commit, let's take a quick look. The workflow is pre-configured to run for main or master branch. We can modify it here to be also applicable for the feature branches. As you can see, workflow is prepared for the self-hosted runners. It uses CMake to build the code. Here we are telling CMake to emit compile commands.json file, which will be used as an input for the C++ test static analysis. And once the code is built, analysis is executed with the run cpp test action. Action takes the compiled commands JSON file generated by CMake and executes the static analysis. There are a couple of options that can be modified here. You can find more details in the actions description. We'll use the default values for our demonstration, which means that our source code will be scanned with the pre-selected collection of static analysis checkers called recommended rules. Once the code is analyzed, C++ test will generate a SARIF report, which will be uploaded to GitHub and presented as the code scanning alerts. We are ready to commit our workflow now. Let's add a short comment and commit the file. Our commit immediately triggered the workflow. Here, this small dot indicates that GitHub is executing the pipeline. Let's take a closer look. Here we can see steps or actions from our workflow being executed on our self-hosted runner, including of course static analysis with C++ test. Once the analysis is done, the SARIF report is uploaded to GitHub and the results are presented in the Security tab's Code Scanning Alerts view. Let's take a quick look at one of reported problems. Here we have a violation of the rule avoid accessing arrays out of bounds. When we click, we are presented with more information. We see the place in the code where problem appears with a comment explaining the violation. If we click Show Paths, GitHub will present step-by-step path with code snippets and additional comments, which is a great help in understanding why and when the problem appears. C++ test integration with GitHub provides a great value here. Ability to review code scanning results directly in GitHub, either in the context of specific check-in or as a part of pull request, streamlines the development workflows and reduces the cost of the compliance process with industry standards. Now let's see C++ test GitHub integration from the developer's activities perspective. For this, I will clone the repository to my local workstation. Let me switch to the terminal. Since this is a fresh workstation, we'll need to perform the initial Git configuration. I'm going to configure now the username and my email. For development, we'll use Visual Studio Code with GitHub and C++ tests extension. Let me open it. As a first step, we need to clone the repository. So let's use clone repository and then clone from GitHub action. I'm already signed into my GitHub account, so I can directly select the repository. When working with a fresh setup, VS Code's GitHub extension will prompt you to sign in. Let's go with GHDemo repository. It will ask about the location. Let's put it in the sandbox folder. We have successfully cloned the repository and we can open this folder in VS Code. The first thing we can do is to download the latest static analysis results generated in the GitHub pipeline. Let's use the C++ test VS Code extensions action to access the results from the latest pipeline. You may be asked to sign in into GitHub, but I'm already authenticated. And as we can see, all the results we could previously see in the GitHub are now downloaded to VS Code. C++ test extension automatically identified the latest results for our current branch. It's a great help and a time saver for developers. They are more productive when reviewing and remediating bigger batches of static analysis violations generated in GitHub pipelines without leaving their preferred IDE. So let's try actually to fix one of the problems. Here we have a violation of do not check for null after the referencing static analysis rule. This is an easy fix. I will modify the code now. Okay. Here we have another violation which we want to accept for now. So I can suppress it. I will enter the reason now. And we are ready to commit the changes and push them to the upstream repository. Naturally, it will trigger the workflow. Initially, we had 5 problems reported. Now we expect 3 problems because we addressed one and one was suppressed. If we go now to GitHub, we can see that the workflow is in progress. Let's give it a second. It finished. We can check the code scanning alerts now. As we expected, there are 3 violations only. Great. This simple use case presents the typical actions performed by developers when working with GitHub. In the real life, development process is likely to be more complex with a large number of feature branches and pull requests. C++ test GitHub integration is proven to support advanced development models. And this concludes my demonstration. Let's quickly recap what we have covered. We have discussed the procedure of adding GitHub workflow with Parasoft C++ test static analysis. We have used the GitHub Marketplace action for C++ test to configure our workflow. We have seen how static analysis results are presented in the GitHub interface. And we have also seen how developers can utilize C++ test VS Code extension and the GitHub integration to streamline their daily activities. Thank you for watching.